Alright guys, moving on to lesson 2.3. Today we're going to look at using the fundamental theorem of calculus. Let's go ahead and we're going to do it two ways. One way is doing it by hand. The other way is with a graphing calculator. Now, we have a little bit of a danger. I'm going to show you guys how to do it with the graphing calculator. It's really easy and it's really fast. But you guys need to show your work on your homework if I tell you to do it by hand. And also, when we do get back to school, and also on your AP exam, there will be parts where you're not allowed to use that calculator. So even though, yes, you could very easily finish almost your entire homework assignment by just punching it into the calculator, and I am going to show you that, I would make sure that you are doing them all by hand unless otherwise indicated. This is your guys' opportunity to practice. In fact, it's actually pretty hard to do it by hand. There's a lot of places to make mistakes. So if you're not practicing this, you're going to lose it, and you're not going to be able to recover it because this is your only opportunity to master it. So make sure you guys don't take the easy road and just use the calculator, even though I am going to show it to you. Okay? All right. So fundamental theorem of calculus. I think we've talked about it before. So basically, if you have a curve represented by the green line there, f of x, and I want to find the area between that curve and the x-axis from x equals a to x equals b, we can do the fundamental theorem of calculus, which means we're going to integrate this function, and we're going to plug in the upper and lower limits of integration. This one here should say lower limit of integration. And then after you integrate it, you get the capital F, right? The antiderivative. You plug in b and a and subtract, and that magically, not really, but magically, gives you the area under the curve there. So that is the fundamental theorem of calculus, and that's what we're going to be doing today. Before we get started, some problems. I just want to compare and contrast two words. Now, we talked about integrals, but we've also talked about the two types, definite versus indefinite, and I want you guys to make sure you know what they are. Indefinite is what we started off with. It's also known as an antiderivative. It's a solution to a differential equation, and the result is a function. It has no limits of integration. So here, I wonder if I have an example. Let me see. I do. So here's an example. This is probably the most helpful part of everything. All it means is you integrate a integrand there, and your result is the antiderivative. Okay? You get a constant of integration. There's no numbers here. The result is a function. It's not a number. So that's what we call an indefinite integral. Now, a definite integral, it's not just a function anymore. Whereas this one, the result is a function. When you do an indefinite integral, it actually represents the area under the curve. It can represent other things too, but for now, that's all we're going to focus on. It's found by doing the fundamental theorem of calculus, and what that means is after you integrate, you plug in your upper and lower limits, which means that it does have limits of integration on it. So you'll have these little numbers right here. So this is the difference between an indefinite integral and a definite integral. An indefinite integral just gives you an antiderivative, which is a function. A definite integral has these little numbers here, and you evaluate it using the fundamental theorem of calculus, and it tells you the area under the curve. So do you understand the difference there between indefinite and definite integrals? All right. We also talked about positive area and negative area in a previous lesson as well. So anytime the area that we're finding is above the x-axis, it's a positive area. When it's below, it's a negative area. So if these were equal, it's possible they could cancel each other out and your answer is 0. Now, if you ever really wanted to find the area and ignore the negatives, you would have to find the area of this piece and then the area of this one and change it to a positive and then add them together if you wanted to find the real true area. But if you just plug it into your calculator from A to B, your calculator is going to keep this one positive and this one negative, and they're going to cancel each other out and you're going to get a lower number. And that's not wrong, it just means something else. So if you're ever being asked to find the true area, which is something we're going to really focus on when we get into Unit 7 at the very end of the year, then we'll have to change it. But in this chapter, that's really not going to be an issue. we're just going to keep them positive and negative and let the answer come out what it naturally is, okay? But that is area under the curve. So this thing is asking us to evaluate each definite integral. All right, so first of all, we have the math to do. And I want to warn you guys, the math is a little bit of a nightmare. You're not going to like it. There's a lot of stuff there, and we're going to have to work on that. That's where all of our time's going to be. But you guys will also notice I gave you a picture here. I did that on purpose because I want you guys to know how to understand what this means on this picture. So what this means is that this equation right here, x cubed minus 3x squared plus 3, that's this line. That's the graph of x cubed minus 3x squared plus 3. Okay? But what do these things represent? Those are my upper and lower limits of integration. Now in my graph, that means this is where I'm starting and this is where I'm stopping along the x-axis. So we're starting at x equals -1. So on my graph, that would be like right about, well, actually let me back up a little bit. I'm going to erase this because it's kind of in my way. So here, you guys can see right here is x equals -1, right? But we want to find where that's at on the line. And I would say it's probably like right about here. And we're stopping at x equals 3, which is like right here. On my line, that's going to be like way up here. Okay, so there's that. Now, what I want to do is I want to find the area that is between the curve and the x-axis. So, I'm going to start with an easy one here real quick. The area between the curve, which I'm going to bring back the purple here now. Oh, that's too big. I don't want to have that. I want to leave that point red, so I'll leave that point red. Okay, so the area between the curve, and well, actually, let me back up. Let's review really quick. The equation is represented by the purple line. And these red limits, that's my starting point at x equals -1 and my ending point at x equals -3. Now, what does, a different color here, let's go with blue. What does this represent? Well, that's the integral. But when you're doing a definite integral, meaning you have the upper and lower limits, what you're really finding is the area between the curve and the x-axis. So let's start off by shading in a simple spot here, okay? So like for instance, this is all the area between the curve and the x-axis in this area. So we want to find that. But there's more, right? We also have some area here between the x-axis and the curve. So it has to be between the curve and the x-axis. So we're going to find that one. And by the way, this one would be negative, right? Because it's below the x-axis, whereas the other one would be positive. And then we also are finding up to here, right? So anything from here and over, underneath that purple line, to the x-axis, and we stop at x equals 3, is right there. And then this one's really hard to see, but it's there. There is a little bit going here underneath. Between the purple line and the x-axis, it's like a really tiny sliver of a triangle. Okay? So there you go. That's that's the area we're finding. And so it's kind of like there's actually 1, 2, 3, 4 different regions. We have like this little triangular region here, and then we have this parabolic region here, and then we have this parabolic region here, and then another little triangular shaped region here. And what we're about ready to do is we're going to find the area of that entire blue space. So before I go any further, I want to say two things. Let's review first of all. This equation is represented by the purple line. these limits tell you where to stop and start. So you need to put a dot on your curve where those x values are at. That's where you start finding the area and where you stop finding the area. And then this integral symbol tells us that we're finding the area between the purple line and the x-axis. Sometimes it's above the x-axis, sometimes it's below, and you shade it all in, okay? And our answer to this is going to represent the entire area, all put together, okay? Now remember, these are negatives, these are positives, so as you guys can see, there's a lot more positive than negative. So I should end up with a positive area, but just know that some of these negatives down here are going to be canceling out some of the positives up here, so it's going to come out smaller than those two big positive ones combined because they're getting subtracted. But anyway, so there's your review of what all that stuff represents. But now I want you guys to know this. Whenever you guys do your student practice, which is coming up very soon, let me actually just show you. Matter of fact, why don't you guys do this now? And before I actually start doing the math, here's your guys' student practice. For your student practice, what I want you to do is I want you to shade the areas that you're finding. So to do that, you're going to need to identify what your function is, like where the line is for that, right? You need to find where to start and stop, and then you need to shade the appropriate areas. So pause the video and see if you guys can shade the appropriate region, because that's actually a skill I want you guys to be able to do, is to turn the math equation into a picture. So shade the appropriate region on that graph. Okay, so that's what you guys should have shaded. Okay, so notice that I've color coordinated it again. The purple line is the parabola you see up there, and that's the equation that's underlined in purple in the integrand. And then you have the upper and lower limits, 3 and 0, which is where you start and stop. So you put a dot at the starting point where x equals 0, and you put a dot at the stopping point where x equals 3. And you'll notice that's where the blue area starts and stops. And once again, the area is between the purple line and the x-axis. So that's what it should have looked like. So what we're about ready to do now is we're going to go ahead and start finding the area of these regions. But I'm going to go back to my problem now that I was doing. So hopefully you guys know how to shade in a graph. You know what the area looks like. That's that. Now we're about ready to get into some pretty intense math. Now here's the honest truth about these. It's not so much that the type of math we're doing is hard. It's just that there's so much calculation. It's so easy to make a mistake somewhere, a tiny little mistake. Okay, so let's go ahead and begin here. Now, you're going to need some space for this. Now, if you guys want to be successful in actually calculating these areas by hand, you need to be neat and you need to show your work. Okay, and if you follow the steps I give you, you'll be less likely to make any errors. Okay, but the issue here is that when you're done with these problems, they'll probably take up about a quarter to a half of a page of writing, depending on how big you write. Okay? And there's tons of room for error when you do that much calculation. So the key to success with these is being neat and organized and double-checking your work. All right? So let's go ahead and begin actually finding the area represented by this integral. Okay, guys, so step one is going to be to integrate. All right? So let's go ahead and begin there. Step one is to integrate. Remember, be neat and take your time, and I would encourage you guys to write down these steps that I'm writing down as well. So I'm going to integrate this. So if I integrate x cubed, I'm going to add 1 to the power and divide by that number. And then I'm going to do the same thing for the next one. Add 1 to the power and divide by that number. And then the last one is just a constant, so with those we just put an x next to it. Now you'll notice that since I did the integration, we're not going to have the integral symbol there anymore. We're going to use brackets now. And our limits go over here on the right side. Okay, so that's going to be your first step. Now, if possible, simplify. You may not always be able to simplify. I can simplify a little bit here, though. I can't do anything with x to the 4th, unfortunately. But this guy cancels out, and I'm left with x cubed. So that's one thing we can do. So step 1, integrate. Step 2, simplify. All right, now this is a very important step here. Okay, this next thing I'm about ready to do is we're going to do the fundamental theorem of calculus, all right? And how you show your work is going to make a big difference, all right? And like I said, none of this is new, right? I haven't done anything new at all. But this is where we're going to make sure that you want to show your work neatly, okay? So now we're going to do the fundamental theorem of calculus. The fundamental theorem of calculus tells you that you integrate it, which we've already done. And after you do that, you plug in the upper limit and the lower limit, and you subtract those results. Okay? So here we go. Now, take my advice on how to show your work here. You're going to write 2 sets of brackets with a minus in between them. Okay? And what is going to go in each of these is, for the first set, you're going to plug in the 3. And for the second set, you're going to plug in the -1. Okay? So here's what that looks like. Now, once again, I encourage, before you plug anything in, start with parentheses. I'll put a little suggestion there. Start like this. You do bracket, bracket, minus bracket, and then you do parentheses. Okay? That's my suggestion. The reason I suggest starting like that is because it helps you avoid problems with negatives. So if you start by setting it all up, it may help you avoid a problem with negatives. So I'm just rewriting the whole thing twice. It's just that in the place of the x's, I'm going to put parentheses. Now where the x was, we're going to plug in the 3. So now this is important. Whichever limit is on top goes here, so the upper limit comes first, and then the lower limit comes second. So, I forgot to label this step. It's the fundamental theorem of calculus. So we're going to plug in 3 to the first set, and we're going to plug in -1 to the next set. This step, in my opinion, is the most important one that you want to be very careful with. Make sure you set it up correctly. Make sure that you plug the upper limit in first and the lower limit in second. The setup should be brackets with parentheses and a big minus sign in the middle. Okay? If you do that, from there on out, guys, it's basic math. You have to remember your order of operations, but after that, it's all basic math. So my suggestion from there, once you get this far, is to start simplifying it. But as you do so, the first thing you're going to want to do is you're going to want to do the powers, if there are any. So in this case, we have 3 to the 8th power. I'm sorry, 4th power. So 3 to the 4th power is 81. 3 to the 3rd power is 27. This isn't a power, but we'll go ahead and do the multiplication. Why not? -1 raised to the 4th power. Well, anytime you raise a negative number to an even power, the negative cancels. So you just end up with 1/4 there. And when you raise a negative number to an odd power, the negative stays. So -1 to the 3rd power is -1, but because of that, there's a negative outside, it becomes +1. You got to watch out for stuff like that. That's where we're all going to get tripped up. Okay? Now, after you've done your powers, and I guess multiplication, and I did some multiplication also, right? I'm going to say go ahead and distribute your negatives. Okay? So, what do I mean by that? I mean this guy right here. Distribute that into this second set. You're subtracting the whole thing, so just go ahead and distribute it in there. After that, you don't really need the parentheses and brackets anymore. You should have done all the math that was necessary for those to be there. But now we're good, so we can go do that. notice all the signs changed. The 1/4 became negative, the 1 became negative, and then the -3 became positive. Okay. All right, now here's the next part. This will save you some trouble. Combine the like fractions. Combine like fractions. I'll actually write it out. Combine like fractions. What do I mean by that? Because sometimes you're going to end up with a bunch of fractions here. That's one of the killers, is you're going to end up with a whole lot of fractions. All right? So find the fractions that match. Like, for instance, 81 and -1/4. You can put those together. What's 81 fourths minus 1/4? Well, you subtract 81 and 1, and you get 80/4. Now, you would do the same thing if you had other fractions up here. I don't have any other fractions. So now I'm just going to combine the rest of these numbers that are together here. So let's see. At this point, you can use your mental math or, whatever you want to do. But -27 and 9, that makes -18. That's going to make -19. That's going to make -16 if I put all four of those together. So I end up with -16 by putting those like fractions together. Okay? Now, can you reduce your fractions? Now, in this case, I can. 80/4 is 20. Now, from here, it's obvious. We're just going to subtract, and I'm going to get 4. But just so you guys know, it's very possible that this fraction won't reduce. So what would you have to do to combine these if it didn't reduce? Well, you would have to get a common denominator. And then you would have to simplify. Now, for my problem, I didn't need to do that. It simplified away, so there was no longer a fraction there. But you got to be careful. Sometimes this fraction will not go away, and so you'll need to get a common denominator in order to simplify. So let's review the steps one more time before I set you guys loose on one of these, okay? So, first step, integrate. You should have brackets at that point with no more integral symbol. If necessary, simplify your expression. Step 3, do the fundamental theorem of calculus, and that's what this thing was about. We spent a long time talking about the proper way to set it up. 2 sets of brackets with a minus in between, and parentheses where the x's were inside, upper limit on the left, lower limit on the right. Okay? After that, it's just a matter of simplifying your result, and that's step 4 there. But step 4 has a lot of room for error, okay? I'm suggesting powers first with multiplication. Then I'm suggesting distributing the negative, combining your like fractions. After that, reduce if necessary. Combine your fractions that don't have the same denominator. Make that your last step. And then simplify. You should be done at that point. So what we're going to do is, I was going to just give you guys a student practice and let you guys jump into one. But I think actually what I'm going to do instead is we're going to do like a guided practice. So I'm going to give you a problem. And what I'm going to do is I'm going to have you guys just do each step one at a time with me. And then I'm going to give you another one where you're going to do it completely on your own, okay? So let's go ahead and do a guided practice, which means we're going to do one step at a time together, because it's not that this stuff is any different or new than what we've been doing. It's just that there's so many places, so much math to do, you can make a mistake. But before we move on, I just want you to know our answer came out to be 4, and what that means is the total area combined, positives and negatives all together, made an area of 4. Okay? All right. So let's go back to yours. You guys shaded this one a little earlier, and it should have looked something like this, right? And now we want to find this area, and we're going to do it using the same process. All right. So I want you guys to do the first step only, please. Do the first step to finding the area under that curve. So pause the video, look at the example we just did, and see if you guys can get the first step done. The first step was to integrate. This is what you should have gotten if you integrated. And by the way, the way you show your work matters, okay? Did you guys remember to get rid of the integral symbol and replace brackets in there in its place? Did you remember to put the limits on the right side now? How you show your work is important. That's good. Go ahead and do the second step. Pause the video and try the second step. There you go. Second step's pretty straightforward, guys. No big surprises there. You just had to simplify the 8 over 2 to become 4. All right, now this is the step that matters. All I want you to do is set it up. Go ahead and do step 3. I don't want you to do any math. You're just setting it up, okay? So go ahead and do step 3. Pause the video here. This is the drum roll one. All right. So here we go. There's your setup. Now, some of you guys might have already plugged it in. And if you did, just remember at the top, the upper limit goes in first. The lower limit goes in second. You gotta love the zeros, guys. Zeros are amazing. It makes your life a lot easier. So now you guys get to try to simplify this thing. So go ahead and pause the video and see if you can take this all the way down to a final answer. All right, so did my powers to begin with there. And then I did my multiplication. So 2 times 27 was 54. Then we got 4 times 9 is 36, etc. All these just become 0. You got to love when you plug in a 0. Everything just kind of goes away, so we don't care about that piece anymore. Which means we can kind of skip the step where we need to distribute the negative in. We don't end up having to do that here. And all we have to do is simplify what's left here. It turns out conveniently that negative 54 does divide nicely by 3, which makes, I wonder if I did that right though, 3. I might not have done that one right. Let me look at that again. I don't think it's 27. I think it's different. 3 goes into 5 once, 8. So it's actually negative 18, which is going to change my final answer too. So it's not 3. Sorry if I freaked you out there. That's going to be 18 minus 6, which is 12. So the final answer should have been 12. My bad. You guys are probably like mad at me now. All right, but anyway, there it is. So the answer is 12. But you see, there's so many places you can make a mistake. But my handwriting's not the best. Some of you guys have beautiful handwriting, but even for my nasty handwriting, you guys see how organized my work is? My steps are labeled. My work is clearly shown. That way, if you make a mistake, it's easy to go back and fix it because you can see. It's like having a clean bedroom. When your room's clean, you can find things a lot easier. Okay, in the same way, if your work's nice and neat, if you made a mistake along the way, you can easily go back and fix it. So be neat, take your time, and I'll tell you, this step 3 is so important, how you start. You should be starting off with brackets, with a minus in between, and then x's wherever those parentheses, wherever those x's are. After that, you just plug stuff in and go for simplifying. All right, so that was one problem where we kind of did as a guided practice, step by step. What I'm going to give to you guys to do now is I'm going to give you guys one to do completely on your own, by hand, without me walking you guys through any steps. So here you guys go. Now I have no idea how hard this one's going to be. I just made it up off the top of my head. It may end up being really easy, but I hope it comes out to have a lot of fractions because I want you guys to kind of see what that feels like while you're working on it. But go ahead and pause the video here. It should take you about 5 minutes, and then when you're done unpausing, I'll have the final answer up here from beginning to end. All right, so here's the answer. This is where you throw your pencil across the room and start cussing. I know you guys, a lot of you guys probably didn't get it. I understand it's frustrating. Maybe I'm wrong. I don't know. We'll see. But let's see what we got here. So here is the problem, right? We have the initial problem. Then with step 1, we integrate it. And when you do that, you put brackets with numbers. Step 2 is to simplify it, but I didn't get to do step 2 because there was nothing to simplify. Sometimes you won't have to. Step 3, this is the important step. Did you guys get that set up correctly? I had my brackets, I had my parentheses, I put the positive 2 in the parentheses on the left, the negative 2 in the parentheses on the right. Next I did my powers. 2 to the 3rd power is 8, 2 squared is 4. And when you do negative powers, remember, negative 2 to the 3rd power is negative 8, and negative 2 to the 2nd power is positive 4. Odd powers don't cancel out negatives, evens do. And so there's that. And then I did my multiplication. So 3 times 4 is 12, right? So and then I reduce. 12 over 2 is 6. Now, this one we didn't have zeros, right? So we actually have to distribute that negative in, which changes all the signs. So that's what I get after changing all the signs. And then I combine the fractions that have the same denominator. So the 8 over 3 and the 8 over 3 can be combined, and all the non-fraction numbers can be combined. And this is what I got. 16 thirds minus a fourth. Now, in order to combine those, we have to get a common denominator. So for the 4, you would imagine that as being 4 over 1, right? And multiply the top and bottom by 3 to get your common denominator, which is 12 thirds. And then from there, do your subtraction, you get 4 thirds. So there you guys have it. And what that represents is the area under the curve from x equals negative 2 to x equals positive 2 for this function. I don't really know exactly what this function looks like. It's a parabola. I know the y-intercept is 0, and the vertex is negative b over 2a, so that's negative 3 over 2 is negative 1.5. So that would probably be somewhere over here. So this parabola would look something like this, I would imagine. And we're going from negative 2, which would probably be like right about here, to positive 2, which would be over here. So the area we just found, 4 thirds, would be this area between negative 2 and positive 2 for the x. Okay? But you don't have to do the picture. That's okay. I was just giving you guys some background there. So that is doing it by hand. Did you get close? That's awesome. All right. If you didn't, don't feel bad. It takes a while to be able to make sure you're being neat and organized enough to avoid common errors that come up, like particularly with negatives and things like that. All right. Now I'm going to give you guys something very deadly. I'm going to give you something that will allow you to finish these problems in under a minute with complete accuracy, and that's your graphing calculator. But it's deadly because you guys do need to know how to do this stuff by hand, okay? So please don't take this as an opportunity to not do the work that you need to do by hand. Unless I say use a calculator, make sure you do it by hand. I know that it's time-consuming, but if you don't practice now, you're not going to remember it later. Trust me. This is your one chance to really focus on this and have it under your belt for later, because after this, it's only going to come up as a quick little review question. So if you don't master it now, you're going to have trouble mastering it later for sure. All right, so we're going to do a graphing calculator. So you guys are going to love this. It's nice and quick and easy. And matter of fact, for you, I'd recommend on your homework, or any problem, you can always just check your answer with a calculator. Why not? Okay, so here we go. Let me bring my, it'll let me, there we go. Let's bring my calculator over here. They don't want to let me bring it over there. Why not? Okay, so follow along with me here. I'll go slowly for you guys. Follow along with me. So the first thing we need to do is we need to put this function into our calculator, okay? So the first thing I want to do is type this into our calculator. Give you guys some pointers along the way. So to do that, we're going to push y equals. Clear out anything that's already in there. All right, so we have a negative fraction. Now remember, this is a negative, it's not a minus. The negative button is down here. The minus is here. Don't get those mixed up, because your calculator if you get them mixed up, your calculator will say error. So I'm going to push negative, and anytime we have a fraction, we have to do parentheses, at least on my calculator. Some of you guys might have a cooler one that's not. So I'm going to have negative, and the whole fraction is going to go in parentheses now. So I have x squared. X squared is, here's the square button if you want to do that, or you could do this button, which is a power button, in 2. But either way, you get x squared. And then divided by 3. Now, some of you guys have a calculator that whenever you push the x squared button or the power button, it puts your cursor up here. So you have to make sure that, if you don't type it right, your calculator will do this. You'll put x squared, and then you're going to push divided by 3, and that's wrong. we want x squared divided by 3. Okay, so to get out of the exponent, you usually just push the arrow button to the right. So this is what it should look like for now. Or if you've got a fancier looking calculator, you should have something that looks like this right now. Just like, oh, I think I did that wrong though. It's not 3, it's 2. My bad. The denominator was supposed to be 2. So I need to fix that here as well. I put a 3 there, but that's wrong. So let me back up and fix that. Which actually is a great teachable moment. So if you ever want to get rid of something, you're going to go back. You're going to push delete, so that gets rid of it. That's this delete button here. And then you're going to push insert. So second, and the same button there, but now it's insert, and then the right number. So if you ever type in the wrong number, you can delete it, and then you can insert it. Okay? And then scroll over to the next spot. Okay, so we've got negative x squared there. Fractions and negatives are touchy with how you enter them in the calculator. And then we have minus 4x. Now that's a minus 4x, right? That's not a negative 4x, that's a minus 4x. So it's minus is right here. Minus 4x minus 10. And there's my function. So the first thing you do is type it in there. And we talked a lot about fractions and negatives and minuses. So that's our takeaways there, as well as inserts and deletes. But anyway, let's get back to actually doing the problem now. All right, so we're going to, at this point, we're going to push graph. And there's my graph. All right. Now, there's two ways you guys can find the integral, a definite integral value like we're doing here. I'm only going to show you one way today. We'll get to the other one later on in the year. But for this one, you're going to like this. It's really cool. So what you guys are going to do is you're going to push second and then calc. And then, as you guys can see here, option 7 has like this little integral symbol with f of x dx. So that's our integral. So go ahead and push 7. And now it's asking, says lower limit question mark. And that means the calculator wants to know what's our lower limit. The lower limit is negative 5. Okay? So we're going to type in negative 5. And remember, negative 5 is not minus 5. Okay, so we push negative 5. And then you push enter. Now we're going to put in our upper limit, which is 2. So negative 2. And then enter. And watch this. You guys are going to love it. Not only does it tell you the answer, which is right here, negative 7.5, but it also shades it for you so you know what area you're finding. And notice that my answer is a negative area because all of this is below the x-axis. So you have a completely negative area. All right? So nice. Makes things a lot easier. So basically, what are the steps? You push y equals, you enter your function, you push graph, and then you push second calc. You push 7 to integrate, enter your lower limit, enter your upper limit, and then enter, and you've got your integral and a picture. So it's very nice to have. You guys could be definitely checking your work this way. So here's one for you guys. Go ahead and take a moment and see if you guys can accurately find the area under this curve from -1 to 1 using your graphing calculator. If you need to pause the video here, go ahead and do so. So for this one, just because it's calculator, I'm going to actually go through it instead of just putting the answer up. So here we go. Negative, we go to y equals, and we're going to type in negative x to the power of 3 plus x to the power of 2, which I can just push my square button here, minus 4. Notice I put a negative here, put a minus here because this one's a negative, this one's a minus. If you got error, that's probably what you did wrong. Next, we're going to push graph, and there's my graph. Now I want to find the area from -1 to +1. So that would be from here to here. It'd probably be like shading there. So what we're going to do is we're going to push second, trace, 7, lower limit, upper limit. So lower limit is -1, upper limit is +1, and there's our answer.